Good afternoon, dear colleagues. I would like to represent you my report with theme Research of Wooden Bearing Structures Behavior under Fire Condition with Use Advanced Methods of Fire Resistance Calculations considering EuroCode 5 recommendations. As known, wooden is dangerous material during fire impact due to its combustibility. Having used modern constructive solving, this fire danger can be significantly decreased, such that constructive solving is the use of combined wooden ceilings. The scheme of such combined wooden ceiling represented on slide 2. On slide 2, result of fire impact of wooden ceilings of such construction has been shown. Also on this slide has been represented the most important issues of calculate method improving of wooden structures fire resistance evaluation. The use of finite element method with nonlinear setting is the one of most perspective way for solving of building structures fire resistance tasks. As a sample for calculate method development, the most distributed wooden ceiling construction was chosen. The calculate scheme and constructive scheme of beams location is shown on slide 3. The feature of fire resistance evaluation tasks of building structures elements is sequential solving of thermal problem and structural problem. In table on slide 4, the basic components of mathematical models for thermal and structural problem solving are shown. The meshing models to fire resistance evaluation task with use of finite element method were built separately for thermal problem and structural problem. These meshing models are represented on slide 5. Structural problem was set only for wooden frame of ceiling. The wooden thermal properties and properties of other materials, thermal conductivity coefficient, specific heat and density are represented on slide 6. The wooden mechanical properties were used to structure problem solving as unsymmetrical diagram deformation recommended by EN 1995-12 2005 EuroCode 5. Also, the thermal expansion deformation was used for solving with this problem corresponded these recommendations. These properties are shown on slide 6. The results of thermal problem solving are represented on slide 7 as temperature distributions on cross-section wooden slab at the different time moments of fire standard regime influence. The results of wooden slab structural problem solving under impact of fire standard regime are shown on slide 8. There are represented maximal displacement curves in relating with fire thermal impact time that correspond mechanical load level applied on top surface of wooden slab. The onset of bearing capacity limit state is identified thanks to building of tangent line before and beyond displacement curve bending. Time of limit state onset is fixed on cross point of these tangent lines. The fire test was conducted for calculate results validation. The slide 9 consists of construction scheme installation for fire test. On this slide, geometrical configuration of cross-section scheme set thermocouples location in the frame beams and load weights were shown. The adequacy validation results of date determined by finite element method, while comparison of this date with experimental date is represented on slide 10. The look of represented curves is shown that these results are well matched. The general conclusions were represented on slide 11. Thank you for your attention.